Let's take a look at page 425 in your workbooks, and we're looking at solving rational equations part 2. So this little blurb at the top just goes through some of the steps, again, considerations in order to solve equations, and specifically this time of equations that we're going to solve might end up looking like quadratic equations as opposed to linear equations like the ones that we previously looked at in part 1. So let's take a look then. So as it says in class example number 1, the previous lesson, we solved that particular equation graphically using your calculator, and we recall, or you can go back and take a look at the solution was x is equal to 0 or x is equal to 2. So let's take a look at how to do that algebraically. So just like in part 1, we recognize that the least common denominator would be x plus 1 times x minus 1, and so we'll multiply each side and each term on the left side and the right side by x plus 1 and x minus 1. So let's take a look. X plus 1 and x minus 1. And this side as well, x minus 1 and x plus 1. And of course the right side 2. And so as soon as we do that, we can see that the x plus 1s are going to cancel each other out here, x minus 1s on this side. So our new and improved equation is 3 times x minus 1 plus 1 times x plus 1 is equal to 2 times x plus 1 times x minus 1. So we'll take a moment to expand and clean things up further. So 3x minus 3 plus x plus 1 is equal to, and hopefully we recognize that that is a difference of squares, the difference of squares being x squared minus 1. So then we distribute the 2 in, so it's 2x squared minus 2. Move everything onto the one side. So let's move everything to the right, or I'll clean up the left side first. So we've got 4x minus 2 is equal to 2x squared minus 2. And so at this point, we'll subtract 4x from each side. And we'll also add 2 to each side. So then we've got 0 is equal to 2x squared minus 4x. And then minus 2 plus 2 is, of course, 0. So that is our now quadratic equation. So our rational equation has now become a quadratic equation. To solve, we recognize that we can either factor or complete the square and apply the square root principle, or quadratic formula if we need to solve algebraically. So those are our 3 options. So obviously factoring would be the quickest way and most efficient way to do that. This one factors nicely with a common factor of 2x. So then we're left with x minus 2. And so that means that either 2x is equal to 0, our little mini equations, 2x is equal to 0, or x minus 2 is equal to 0. That tells us that x is equal to 0, or x is equal to 2. So that solution matches, of course, what we found graphically to be true. Okay, at the same time, I know we did that before, but always good to remind ourselves what are our non-permissible values. The non-permissible values looks at the denominators, so we can't have x plus 1 equaling 0, so x plus 1 not equal to 0, so x cannot be negative 1. Similarly, x minus 1 cannot equal 0, so x cannot equal positive 1. Since our solutions are neither negative 1 or 1, then our solutions both stand. Good. So let's take a look at the next one. So what we want to do then is they've indicated cross multiplication, but really what is it that we're doing is that we want to multiply both sides by x plus 1. Prior to doing that, I would always suggest that you first factor the numerator. So let's do that, because perhaps we can simplify and we might not even have the fraction to begin with. So let's do that then. So we would have x squared minus 5x minus 6 factors to then x plus 1 times x minus 6 all over x plus 1, and that equals to 2. Okay, and so we can see here that nicely x plus 1 actually simplifies itself, and so we're left with then x minus 6 is equal to 2, add 6 to both sides, so x is equal to 8. Our non-permissible value is x cannot equal -1, which it does not, so then we're good to go. So hypothetically speaking, though, let's pretend that you forgot to factor first, because that happens. So instead, let's decide that rather than factoring, you decided to multiply both sides by x plus 1 in order to get rid of that denominator. So you've got x squared minus 5x minus 6. That was over x plus 1 and is equal to 2, and multiply the right side by x plus 1 as well. So in this case, the x plus 1's cancel each other out. So we're left with x squared minus 5x minus 6 is equal to 2x plus 2. We'll move everything over to the left side since we have a nice quadratic equation. So then we've got x squared minus 7x minus 8 is equal to 0. Then finally we realize that, oh yes, we can factor. And factoring is, of course, how we can solve a quadratic equation, especially when it's set to 0. So we factor, we've got x minus 8 times x plus 1 is equal to 0. So that means that x minus 8 equals 0, so x is equal to 8, or x is equal to -1. So if we happen to glance at the other side, you can recall that our solution is only x is equal to 8. So why is it in this case that with our quadratic we end up with two solutions? Well, of course, if you look further to the left, remember our permissible value was -1, and that was one of our solutions. So that means that we need to reject this because it is a non-permissible value, leaving us with only x is equal to 8. So ideally, factor first. If you can simplify, you can see it also took us a lot less time to get to that same solution. Okay. So explain why one of the solutions to the quadratic equation does not satisfy the original equation, and we can say that because x equals -1 is a non-permissible value, and of course, why is it a non-permissible value is if we were to substitute it in, it would lead to us dividing by 0. So it would be then as -1. You can even think about it at, if we were to substitute it into the numerator, we'd have -1 squared, which is 1 plus 5 minus 6, which is 0, and the denominator is also going to be 0, and that, of course, is not only undefined, but it definitely does not equal to 2. Okay, so it would lead to 0 over 0, which does not equal to 2. Okay, so let's take a look at these cases then. So try solving both of them, and the verification, of course, is the substitution back into the original equation where left side equals to the right side, and consider your non-permissible values as well. So hit pause and come back when you've completed your solutions. So we can see in that first example, we've multiplied everything through by x, leaving us with x squared plus 2 is equal to 3x. Move everything onto one side to set it to 0, and we now have a quadratic equation to solve. Our first thing to do is to try factoring, which is the most efficient way, especially since it factors quite nicely to x minus 2 times x minus 1 equal to 0. So that means that x is either equal to 1 or 2. And our non-permissible value is, of course, x cannot equal 0 because x is in the denominator on its own as a factor. Since that does not contradict our solutions, then our solutions stand, but we do want to verify just to be sure. So we substitute first x equals 1 into the left side, the right side to see that they're both equal, and then again x equals 2 into the left side and the right side to ensure that they are also equal. So that confirms that our solution is x equals 1 and x equals 2. So in our second example, I've taken the time to factor x squared minus 4. It's a very simple difference of squares, x plus 2, x minus 2. So then I'll multiply both sides by x plus 2 minus 2 because that would be our least common denominator. And that gets rid of our denominators really nicely. And so we're left with then on the left side just x, and then on the right side 2 times x minus 2. We'll distribute that over to have 2x minus 4 and then subtract x. So we are left with a very simple 0 is equal to x minus 4. That means that x must equal 4. It doesn't contradict our non-permissible values, and therefore x equals 4 should be our solution. Just to verify, we substitute that into the left side and the right side of the original equation, and we can see that left side and right side are equal both to 1/3, so that is indeed our solution, x equals 4. So let's take a look then at the next example. And well, that's a nice heading, an equation with no solution. So we already know that it has no solution. So let's see why that is the case. So we can see that denominator of x minus 3, which we don't love. So we will multiply every term in here by x minus 3. So multiply this first term by x minus 3, which is the 4 by the x minus 3, and then the right side also by x minus 3. And that, of course, gets rid of our denominators really nicely. That leaves us with x plus 8x plus 10, minus 4 times x minus 3 is equal to 10x plus 4. And we'll distribute that negative 4 in. So we have 8x plus 10 minus 4x plus 12 is equal to 10x plus 4. And let's clean things up. So just on the left side, we've got 4x plus 22. That is equal to 10x plus 4. So then we'll subtract 10x. So that gives me negative 6x. And then I'll subtract 22. That's equal to negative 18. Divide both sides by negative 6. So then x is equal to positive 3. When we look at our restrictions, though, x cannot equal, well, x minus 3 can't equal 0, so that means that x cannot equal 3. But since that definitely conflicts with our solution, then we need to reject that only solution that we found. Therefore, that tells us there is no solution that is possible. So what does that mean if you were to put that into your calculator to graph? Remember, looking at a solution, it's saying for what value of x are we going to have an intersection point? And if there is no solution, then that of course means that there is no intersection. Okay, so please let me know if you have any questions and complete the assigned work.